Hello again. As we move toward remote instruction, there will be some parts in our book some lessons or investigations that we may skip. Um, this investigation 9, however, is extremely important. So we will break this investigation up into 2 parts. And as you can imagine, since this is a class activity, it's very difficult to do with none of you sitting in here. So we will go about this the best that we can. There will be times that I tell you to pause the video, to work on a problem and then restart it, and we'll explain how to do it. So just open your books to page 624. Make sure you have your math notebook for taking notes in and writing how to work these out. You will also need several sheets of graph paper today, as this activity has to do with graphing functions. Okay, so if you need to grab those supplies, go ahead and pause now and get your supplies so that we can get started. Okay, so investigation 9, page 624. It says, as we've seen, functions can be displayed on graphs. And to graph a function, we use XY pairs. Okay? So they give us in the book, their first example they give us is the function y equals 2x. Okay? And they go ahead and give us some XY pairs. Okay? If x is 0, we put 0 in for x. 2 times 0 is 0 to get y. If x is 1, 2 times 1 is 2, okay? And on and on, okay? So they go ahead and they give us this XY chart, and hopefully you will see by now that our pairs of XY pairs give us coordinates, okay? And our first coordinate here is 0, 0, then 1, 2, 2, 4, and 3, 6, okay? So they've graphed these pairs that satisfy this function. It says, although the table lists only 4 pairs of numbers for the function, the graph of the function includes many other pairs of numbers that can satisfy this function. Okay? So I'm going to go ahead and complete the line that goes through here. I'm going to choose my option that has an arrow on both ends because this function continues in both directions. Okay? And what they're saying is that just because we only noted 4 pairs of numbers that satisfy this function, we can see that there are many other points on this line that satisfy this function. Okay? Here is our 0, 0, 1, 2, 2, 4, 3, 6. Hopefully you see that 4, 8 also satisfies it. Okay? Hopefully you can see that there are more points that will satisfy this function. Every point that sits on this line will satisfy the function y equals 2x. Okay? Go ahead on to page 625. Now they're going to show us the relationship between the length of a side of a square and the perimeter of the square. Okay? So here is our function rule. Okay, to find the perimeter of a square, we multiply the side length times 4. Okay, we've done this before. So perimeter equals side length times 4. Now, a lot of times when we're dealing with functions, we talk about input and output. Remember, input is always what we consider our x value. So if I say my side length is 1, I would put 1 in for s. 1 times 4 is 4. That gives me my output. Okay, input and output. Okay. So they gave us a table of values. This one here, if my side length is 1, my perimeter is 4. If my side length is 2, perimeter is 8. If my side length is 3, perimeter is 12. Okay, and they went ahead and graphed these points. Okay, and they formed a line here to show that every point on this line would satisfy this function. Okay? Look at number 1. It says the graph of this function is a ray What are the coordinates of the endpoint of this ray? Go ahead and answer that in your notes. The coordinates of the endpoint of this ray. And then why is it a ray and not a line? Go ahead and answer that in words in your math notebook. Press pause, answer the questions in number 1, and then begin the video again. Okay, so the coordinates of the endpoint of the ray are the origin, 0, 0. Okay, and the reason that this is a ray and it doesn't continue this way as a line is because when we're dealing with lengths on the sides of a square, we don't have negative lengths, okay? So we're only going to have positive values for our side lengths and perimeter, okay? Now, go ahead and pause this video and answer number 2 and number 3 in your notebook. When you get those answered, start it back up again, and we will go over those. Okay, number 2. Notice the graph of the function is straight and not curved. The function p equals 4s, that's the first one we did on page 624. It's a straight line and not a curved line. Imagine 2 squares with side lengths of in which the side lengths of the larger square are twice the lengths of the smaller square. And they wanted you to draw the squares and then find the perimeter of each square. What effect does doubling the side length of the square have on the perimeter? Hopefully you discovered that when you double the side length, you double the perimeter. Okay, so if I had a square and each side measured 1 centimeter, and it said make the larger square the side lengths twice what the smaller ones were. Okay, so on this one my perimeter is 4. On this one, my perimeter would be 8. So when I doubled the lengths of the side, I also doubled the perimeter. Okay? Now, number 3. Number 3 says the relationship between the length of a side on an equilateral triangle and the perimeter is a function that can be graphed. Write the equation for the function using s for the side length, p for the perimeter, and then make a table of pairs for side length 1, 2, and 3, and then draw them on a graph. Okay? Hopefully, you got this equation for the perimeter of your equilateral triangle. To get perimeter, we take the length of the side and multiply it times 3. Since each side is the same length on an equilateral triangle. So I made a table of values. If my side length is 1, my perimeter is 3. My side length is 2, my perimeter is 6. Side length is 3, perimeter is 9. And then I took those xy values, 1, 3, 2, 6, 3, 9. I graphed them here, and I drew a ray through those points. Okay, so hopefully your number 3 looks like my number 3. Okay, now we're at the very bottom of page 625. It says rates are functions that can be graphed. Many rates involve time as one of the variables, and then they give us an example. Speed is a function of distance and time. Suppose Sam enters a walkathon and he walks at a steady rate of 3 miles per hour. So then they give us the relationship between his distance and his time walking. They said if he can walk at 3 miles per hour, so if we take 3 and multiply it times every hour that he walks, we'll get how far he walks. Okay? Now, I represent that with this function here, d equals 3h. Okay? And then on the top of page 626, they give us a table. Okay, for if he walks 1 mile, if he walks 2 miles, if he walks 3 miles, and then they graph that. Okay? Now go to the middle of the page. Notice that we labeled both axes of the graph. Also notice we adjusted the scale of the graph, so each tick mark on the horizontal scale represents 1/4 of an hour. Okay, so on their graph in the book, they, instead of going 1, 2, 3, 4 right next to each other for the hours, they spaced out the hours with tick marks. Okay, So go ahead and pause the video. I want you to complete numbers 4 through 7 in your notebook and on your graph paper. Be careful to label your x-axis exactly how they tell you to in the instructions for number 4. Okay, you're not going to go 1, 2, 3, 4 hours. You're going to put some space between the hours. Okay, so go ahead and pause your video and complete numbers 4 through 7. Okay, so this is what your graph should look like. Okay, it says, suppose instead of going 3 miles per hour, he was able to walk 6 miles per hour. And he did that for 2 hours. Okay, and then they wanted us to make a table that showed how far he jogged after 1 hour and 2 hours. So after 1 hour, 1 times 6 is 6. He had jogged 6 miles. After 2 hours, he had jogged 12 miles. Okay? And then it says to create a graph, let every tick mark on the time axis represent 10 minutes. So down here, my 1 hour and 2 hour are not right next to each other because I spaced it like they said. 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, 1 hour. And again this way. Okay? So that's number 4. Number 5 says, refer to the graph to find out how far he jogged in 40 minutes. Well, here's my hour. So 10, 20, 30, 40 minutes is here. So I can travel up this way. Here is the point where he had been jogging for 40 minutes. So let's go here and see 1, 2, 3, 4 miles. So the answer to number 5 is that he had jogged 4 miles. Number 6, refer to the graph to find out how long it took him to jog 9 miles. Well, here's my miles, here's my distance on this one. So I went ahead and labeled 9 here. So if I go across, I can see, whoops, here is the point where he had been jogging for 9 miles. So let me come down to see how long that took. Okay, so I'm going down to here. Well, here's 1 hour. 1 hour 10 minutes, 1 hour 20 minutes, 1 hour 30 minutes. So that's 1.5 hours it took to jog 6 miles. Or 9 miles, rather. Okay? Now number 7 says, why is the graph of the distance Sam jogged a segment and not a ray? Well, the answer to that is way back in number 4. It says that Sam jogged at a pace of 6 miles per hour, but he only did it for 2 hours. Okay? So we're going to stop our graph at 2 hours because he didn't jog any longer than that. Okay? Okay, go ahead and get this information in your notes about direct variation. A direct variation. These are the relationships that we've been talking about so far today. These were all direct variations. A direct variation is a relationship between two variables in which a change in one of the variables results in a proportional change in the other variable. Now that's a lot of words, okay? But basically it's talking about the relationships that we've been looking at so far, like perimeter of a square, okay? If I know my side length and I multiply it times 4, I'm going to get the perimeter, okay? So way back in which number was it where we made the squares that got bigger? Number 2, okay? When we made our square bigger, our perimeter also got bigger, okay? So in a direct variation, our pairs form a proportion, okay? So let's look at our pairs that we had for the perimeter of a square, okay? If my side length was 1, my perimeter was 4. Side length of 2, perimeter was 8. Side length of 3, perimeter was 12. Well, let's see if these pairs form a proportion. 1 and 4, 1 is to 4 as 2 is to 8. Do those form a proportion? Yes. Let's look at the second 2 pairs, or the last 2 pairs. 2 is to 8 as 3 is to 12. Do those form a proportion? Yes. So that means this relationship is a direct variation. As my sides increase in length, my perimeter increases. Go ahead and pause the video and answer number 8. Okay, number 8 is talking about the number of hours that Gina works. Okay, if you're talking about an hourly wage, this is a direct variation. The more hours you work, the more money you get. Okay, so it says select 2 of the pairs of numbers from the table and use them to form a proportion. Are the cross products equal? Well, if you did 1:5 is 2:10, those form a proportion. The cross products are equal. No matter which two pairs you choose, you're going to get the same cross product. Okay? Now, when we talk about direct variation, this is typically the formula that we're going to use. Y equals Kx. It should look very familiar, like P equals 4S. Okay? The K is what we call the constant. Okay? The constant. In our formula of P equals 4S, 4 was the constant. Okay, it doesn't matter how long the side is on the square, I'm going to multiply it times 4 to get the perimeter. Okay, so 4 is going to remain the same in this equation. Okay? Notice as the input increases, the output also increases. Again, if my side length increases, my perimeter is going to increase. If the number of hours I work increases, the amount of money I earn is going to increase. Okay? Go ahead and pause the video and answer number 9. Okay, so let's look at number 9. They ask us to find which one is not an example of direct variation. Well, let's look at A, the length of the side of a regular hexagon and the perimeter of a hexagon. Well, I'm going to ask myself, if the length of a side increases on my hexagon, is my perimeter going to increase? Yes, so that one is a direct variation. B, the number of books in the stack and the height of the stack. Okay, so I've got a stack of books. If I add more books to the stack, is the height going to increase? Yes, so that one is a direct variation. The speed at which I travel to school and the time it takes to get there. Okay, so I'm thinking, if my speed increases, is the time it takes me to get to school going to also increase? Uh-oh. Nope. If my speed increases, then the time it takes me to get to school decreases. So this is the one that is not a direct variation. Okay? Okay. Let's go on. Top of page 628. The graph of a function with a direct variation is a straight line which includes the origin. Make sure you get this in your notes. Okay? If a graph is of a direct variation, it's going to be a straight line, not a curved line, and it's going to go to or through the origin. Okay? So pause the video and go ahead and look at numbers 10 and 11. Answer those in your notebook. Hint, the second part of number 11 has already been started for you in your instructions. Go ahead and complete those now. Okay, number 10. Which graphed function is an example of a direct variation? So we are looking for something that shows the graph of a straight line that goes to or through the origin. Okay, I'm going to start at the end. D, it is a straight line but does not go through the origin. It's not your direct variation. C, that one's not even a straight line. We've got a curved line. B, straight line but does not go through the origin. So A is our answer. It is a straight line and it goes through the origin. So it meets both criteria. Okay? Now number 11 is our last one for today. The large carousel at the fair makes 3 revolutions per minute. So it's going 3 times around, the carousel goes like this, 3 times around per minute. Okay? And it operates for 4 minutes at a time. So when you get on the carousel for a ride, you get a 4-minute ride, and it goes around 3 times per minute. So they wanted you to draw an input-output table and then graph it. Okay? So you should have drawn your equation of this. Okay? 3 per minute will give you your number of revolutions for for however many minutes you ride. Okay? And at 1 minute, you've gone around 3 times. 2 minutes, you've gone around 6 times. 3, 9, 4, and 12. That's what your function table should look like. Okay? Now the last part says to plot the numbers on the coordinate plane and draw a segment through the length of the ride. Okay? They actually drew plotted the points for you there in your book, but they wanted you to create the segment through them. Okay? So you should have drawn a line from 0 through those points that ended at where 4 and 12 meet on the graph. Okay, it's a segment because the ride is only going to last 4 minutes. It's not going to be a raid. Okay? Okay. In summary, it says, there are 2 requirements for a function to be a direct proportion. Okay, you're going to need to get to the point where you memorize these, okay? It has to be a straight line which goes to or through the origin. Okay? So 0, 0 will be one of the points on the line. Okay, so we're going to stop there for today. Part 2, we will look at the other kind of variation, inverse variation, okay? The only homework you really have for tonight is to complete your practice assignment in Delta Math. We do not have any assignments from the textbook today, okay? You guys have a great day. See you next time.